In this video, we're going to look at how to solve literal equations. Before we do that, let's talk about what a literal equation is. A literal equation is an equation that involves more than one variable. So oftentimes these equations could have 3 or 4 variables in them, and that's what makes them a little more difficult to solve because we're used to seeing more numbers in our equations than variables. So when you're given a literal equation, you'll be told which variable you need to solve for. So you're going to work on isolating that variable by getting everything else to the other side of the equation, whether it's a number or whether it's another variable. So if we look at number 1, we have a equals 9b, and we want to solve this equation for b. So sometimes what I do is I box in or circle the variable that I know I want to get by itself so I don't lose track of what I'm doing as we work. This one's a pretty simple one because the only thing I have to get rid of is the 9 in front. And remember, anytime you have a number sitting in front of a variable, that's just multiplication. So the inverse of multiplying would be dividing. So I'm just going to divide both sides by 9. Now normally when we divide, we're dividing a number by another number, so we get a numerical answer. But this time we have a variable divided by a number, and we don't know what that variable is, so there's nothing we can do with this side of the problem except leave it as a divided by 9 equals b. So our b is isolated, so that's our final answer. For number 2, we want to solve for the variable u. Okay, so u is right here. So let's look at what's being done to the u. We have an x in front of the u that's being added, and we have a 2 after the u that's also being added. We can get rid of both of those at one time, or we can do them separately. I'll do them separately this time. So to get rid of this plus 2, we need to do the inverse operation, which would be to subtract 2 from both sides of the problem. On the right, it's going to cancel. On the left, we're going to have w minus 2. Those are not like terms, so we can't put them together, equals x plus u. And I'm still going to box in u to let me know that I'm not finished yet. I still have an x being added to the u, so I want to subtract that x as well. So these are going to cancel. And on this side, I'm going to have w minus 2 minus x equals u. So that would be your solution to that problem. For number 3, we have p equals 4 over x, and we want to solve for x. Now this one's a little different because our x is actually in the denominator of the fraction. So the first thing that we want to do is get the x out of the denominator. If it's in the denominator, it's being divided. So the opposite of that would be to multiply both sides by x. So on the left hand, we have x times p, which is just xp. Over here, your x's are going to cancel, and we just have 4. Okay, I'm still trying to get this x by itself, so now I've got to get rid of the p that's with it. Remember, if they're side by side, that's multiplication, so we want to divide to get rid of the p. So those cancel, and we end up with x equals 4 divided by p. Okay, for number 4, we have negative 3x plus 2y equals c, and we want to solve for y. So y is right here. Okay, so we're going to need to get rid of the 3x, the negative 3x, and we're also going to need to get rid of the 2. But remember, you always get rid of your addition and subtraction before your multiplication. So we're going to take care of the 3x first. And since that's all together in one term, we can just add 3x to both sides. So we're left with 2y equals c plus 3x. And I'm still trying to get y by itself, so I need to get rid of the 2 out front now. That's multiplication, so I'm going to divide by 2. And when you divide, you want to divide everything by 2. You can put a bar under the entire right side and put a 2 under it, or you can divide each individual piece by 2. So there's 2 ways to write this answer. We can say y equals c plus 3x over 2, or If we divided them individually, it would be c over 2 plus 3x over 2. And both of those would be considered correct. Okay, for number 5, we have 10abc equals 4. And we want to solve for a. So I'm going to box in the a. So to do that, we've got to get rid of the 10 and the b and the c. Now, because all of these are sitting right next to each other, that means they're all being multiplied. So to get rid of each of these things, we're going to have to divide each one. But rather than doing that in 3 different steps, we can do it all in one step. We can divide this entire side by 10 and b and c. And whatever we do to one side, we have to do to the other. 10b, c. So on the left, the 10's cancel, the b's cancel, and the c's cancel, and we're just left with a equals 4 over 10bc. Now, technically that's the right answer, but it's not in reduced form. In math, you always want to reduce your answers if possible. So if we look at these two numbers, 4 and 10, we know that they're both divisible by 2. So we can simplify that. 2 goes into 2 twice. 2 goes into 4 twice, and 2 goes into 10 5 times. So we'll have a equals 2 over 5bc. Okay, for number 6, we have v equals rs over t, and we want to solve for r. So we have to get rid of the s that's beside the r and also the t under the r. So we have multiplication and we have division. I think that it's easier to work with if we go ahead and get rid of the t that's in the denominator so we're not dealing with fractions anymore. So since that's being divided, I want to go ahead and multiply both sides by t. Those are going to cancel. So the left side would be tv, the right side would be rs. And then I'm going to keep boxing in my r to let me know that I've still got to keep going because it's not by itself yet. Now I need to get rid of this s. And it's multiplication, so I'm going to divide both sides by s. So we have tv over s equals r. And now our r is isolated. And the last one, number 7. W minus x equals y minus z. And we want to solve for z. So we want to solve for this variable. Okay, so we do have a y out in front of the z. Even though there's a minus sign here, the y itself is still positive. So I want you to realize that because the y is positive, to get rid of it, we have to subtract it. A lot of people will look at this sign and think that we're subtracting y, so they add it. But when you're looking and trying to decide whether you're going to add or subtract, go by the sign in front of what you're trying to get rid of. So those are going to cancel. On the left, we're going to have w minus x minus y. And on the right, we're going to have negative z. So moving that y over did not get rid of my negative, so now I need to get rid of that. And when we have a negative in front of a number, there's an understood 1 with it. So I can get rid of the negative by dividing everything by negative 1. So these are going to cancel. All right, when we divide by negative 1, all we're doing is we're changing the signs on our variables or our numbers, whatever we're dividing. So this w that was positive, when I divide by negative 1, now it's negative. The x that was negative divided by negative is now going to be positive. And then the y that was negative divided by negative is also going to be positive. So z equals negative w plus x plus y. And these variables can be in any order as long as they still have the right sign. So another way I could write this would be z equals x plus y minus w. I changed the order, but I made sure that they all kept the same sign. So there's several different ways you could write that answer. Now I want to talk about some literal equations that may look a little bit familiar to you. This may seem like a new concept, but you've actually been using literal equations for a really long time. If you think back to some of your geometry formulas that you've had to memorize over the years, all of those would be considered literal equations. For example, the area of a circle. The formula for area of a circle is area equals pi r squared. So you have two variables in that equation. Now what we're used to doing is finding the area if we're given the radius. But now that you know how to solve literal equations, you could be given the area and have to find the radius because you know how to solve for either variable now. Another example, circumference of a circle. Circumference of a circle is c equals 2 pi r, or c equals pi d, where d is your diameter. The same thing. Normally we find circumference because we're given the radius or the diameter, but now that you know how to solve literal equations, if you know the circumference, you can find the radius, or if you know the circumference, you can find the diameter by isolating the new variable that you're solving for. Perimeter of a rectangle. A rectangle has length and width, so to find the perimeter, we usually do 2 length plus 2 width. So now you could solve a problem where you already knew the perimeter and you already knew the length, but you wanted to find width instead. You would isolate that variable. Or if I knew perimeter and I knew width and I wanted to find length, I could isolate that variable. So all of these formulas that you've gone over in the past are actually literal equations. And so now that you know how to solve for any variable, you can manipulate those equations to find whatever you're missing.